Welcome to this video on acids, bases, and pH. We'll cover everything from the basic definitions of acids and alkalis to the pH scale, strong versus weak acids, concentration, different indicators, and the methods for making various salts. Acids are substances that produce hydrogen ions, or H, when dissolved in water. These ions are responsible for their characteristic properties. Acids can also be described as proton donors. Properties include a pH lower than 7, turning blue litmus paper red, and reacting with metals to produce hydrogen gas and salt. A base is any substance that can neutralize an acid. Alkalis are bases that dissolve in water to produce hydroxide ions, OH. Alkalis have a pH greater than 7, turn red litmus paper blue, and feel soapy to the touch. Examples include sodium hydroxide and calcium hydroxide. The pH scale ranges from 0 to 14, measuring acidity or alkalinity based on the concentration of H ions. pH 0 to 6 is acidic, with lower values indicating stronger acids. pH 7 is neutral, where H equals OH concentration. pH 8 to 14 is alkaline, with higher values indicating stronger alkalis. Remember that the scale is logarithmic, meaning a one-step change, is a 10-fold change in H concentration. A strong acid completely ionizes in water, releasing 100% of its protons, such as HCl. A weak acid only partially ionizes, shown with a reversible arrow, like ethanoic acid. Weak acids have a higher pH than strong acids at the same concentration because fewer H ions are produced. Remember, strength is about ionization, not concentration. Concentration is the amount of solute dissolved in a given volume of solution. Concentrated means a large amount of acid in a small volume of water. Dilute means a small amount of acid in a large volume of water. Strength is about ionization, while concentration is about the amount of acid present. Confusing the two is a common mistake. A universal indicator changes color across the full pH range, giving an approximate pH value. Colors range from red for strongly acidic, pH 1 to 3, to violet/purple for strongly alkaline, pH 11 to 14, with green indicating neutral, pH 7. For highly accurate measurements, a pH probe is preferred over the indicator. Litmus paper is a simple indicator that only tells you if a solution is acidic or alkaline, not the exact pH. Blue litmus turns red in acid, and red litmus turns blue in alkali. Neutral solutions cause no change. A helpful memory tip is blue to red equals acid ahead, and red to blue equals alkalis true. When a reactive metal reacts with an acid, a salt and hydrogen gas are produced. The hydrogen gas can be tested with the squeaky pop test. Metals above hydrogen in the reactivity series react with dilute acids, such as zinc reacting with hydrochloric acid to form zinc chloride and hydrogen. The reaction between an acid and a base is called neutralisation, producing a salt and water. If the base is a carbonate or hydrogen carbonate, carbon dioxide is also produced. The salt's name comes from the metal in the base and the acid anion. For example, hydrochloric acid forms chloride salts. Neutralisation is the chemical reaction between an acid and a base to form salt and water. The ionic equation ISH plus OH yields hydrogen oxide. This reaction is important in everyday life, such as in indigestion remedies, agriculture to neutralize acidic soils, and in industry to clean up acidic waste gases. Salts are formed when the hydrogen in an acid is replaced by a metal or ammonium ion. The method used depends on whether the salt is soluble or insoluble. There are three main methods: acid plus excess base, precipitation, and titration, which is also known as alkali neutralization. You must know the solubility rules to select the correct method. To make a soluble salt, such as copper 2 sulfate, react acid with an excess of an insoluble base, like copper oxide. The steps: Airy reaction and filtration, evaporation to concentrate the solution, crystallization by cooling, and finally, drying the crystals. This process ensures all the acid is neutralized. Insoluble salts are made by precipitation, mixing two solutions whose ions combine to form an insoluble product called a precipitate. The process involves mixing, filtering the mixture to collect the solid precipitate, washing it with distilled water to remove impurities, and drying the precipitate. The ionic equation only includes the ions that form the precipitate, not spectator ions. Titration finds the exact volume of acid needed to neutralize a known volume of alkali. The 5 steps are setting up the burette, preparing the flask, performing a rough titration, performing accurate titrations, and calculating the concentration of the unknown solution using the moles equation and molar ratio. Titration is a required practical. Key equipment includes the burette for variable volume, the pipette for fixed volume, and the conical flask for swirling. Common errors to avoid include air bubbles in the burette tip and reading the meniscus incorrectly. Always aim for concordant results within 0.10 cc for accuracy. Ionic equations simplify chemical reactions by showing only the species that change. To write one, start with the balanced equation, split soluble ionic compounds into ions, but leave solids, liquids, and gases as full formulas. Cancel the spectator ions to get the simplified ionic equation. State symbols are essential, and missing them will result in mark deductions. Common exam questions cover strong versus weak acids, salt preparation, ionic equations, and pH changes in titrations. Remember that strong acids fully ionize, making them stronger at the same concentration. Salt preparation requires filtering and crystallization. The dramatic pH change near the endpoint is due to the logarithmic nature of the pH scale. Essential exam tips include learning solubility rules and the distinction between strong/weak acids and concentrated/dilute solutions. Always include state symbols in ionic equations and use precise language like concordant results for practical questions. Remember that the pH scale is logarithmic. This quick recap checklist covers core concepts like acid/alkali definitions, the pH scale, strong/weak acids, indicators, and salt preparation methods. It also includes titration precision tips and key ionic equations. Focus on understanding the why behind each reaction for better exam success. Good luck with your GCSE.